Hello, Math 130 students. We are going to pick up on page 5, section 5.3. Now we will be adding and subtracting rational expressions. So remember that whenever you add or subtract fractions, you need the same common denominator. So for these warm-up problems, yes, you can do them on your calculator, but I want to go through the mechanics to remind you how we add and subtract fractions, okay? Making sure that we have the same denominator. So here, for number 1, because our denominator is 4, then what we get to do is keep that same denominator and we add 1 plus 2, which gives us just our 3 over 4. So hopefully that should be somewhat of a reminder. Now, what's different about number 2 is that we have different denominators. So because we have different denominators, we're going to find the lowest common denominator, right? So if I have a 5 and a 7, the LCD of 5 and 7, so the least common denominator in 5 and 7 is going to be 35. And you might be thinking, well, how the heck is she getting 35? Well, let's look at our multiples of 5, and let's look at the multiples of 7. I have 1 times 5 is 5. 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20, and we have our 5 times 7 is going to equal to a 35. And over for our 7s, we have 1 times 7 is 7, 2 times 7 is equal to 14. If we keep going along the list, we're going to have 5 times 7 is equal to 35. So the very first number that they both share in common between 5 and 7 is going to be 35. Okay? So that is how I'm going to get my lowest common denominator of a 35. So now that I've explained that, now I'm going to rewrite my fractions. So I have a 2/5 minus a 3/7. So since I want the lowest common denominator to be 35, I'm going to multiply that first fraction by 7. And whenever I do the bottom, I must do to the top. So the second fraction to get to 35, I must multiply by 5. So now I really have a 14 over 35 minus a 15 over 35. So my denominator is 35, thank goodness, and 14 minus 15 is a -1. So I have my answer as a -1 over 35. Now for number 3, remember you can always put a 1 as a default denominator. That doesn't change the value. So here my LCD is going to be a 9. So I multiply this first fraction, top and bottom, by a 9. So I'll get an 18 over 9 is equal to my, not equals, but plus 2/9. So 18 plus 2 will give me 20, and I have my denominator of 9. So that was just a little warm-up. That's nothing new. These are things that people in the Math 130 should understand, fractions, whether it's on your calculator or something that you've done, in high school or junior high and in some elementary schools as well. So hopefully that was a little, review for you guys. And some of you guys haven't taken math for a while, so I totally get it. And that's why I have it, to make sure that, you guys are, remembering this stuff. So now when it comes to the algebra part, we're going to do the exact same thing with adding and subtracting fractions, except now we're going to do this with polynomials. So again, remember, the nice thing about fractions that if we have the same denominator, then all we have to do is either add or subtract the numerator. So here, let's take a look at the denominator. 2x minus 1. Perfect, they're the same. So I know that my answer is going to have a 2x minus 1 in it. Perfect. So now all I have to do is just add my numerators together. Notice how it's being added together. So I have a 5x plus 3. Nothing can cancel, nothing can simplify, nothing can factor. That's as far as I go. Perfect. Now looking at number 2, I have a denominator, and that denominator is x minus 4. Perfect. Now I just have to be strategic now because it's subtraction. So it's subtract that entire second fraction. So I really have an x squared, and because of that subtraction, it's minus x minus 12, okay? Because I had a negative here. So now I can factor. If I'm using the AC method, I would have a positive 3 and a negative 4. So my numerator becomes x plus 3, x minus 4, and that denominator is my x minus my 4. But I know that x minus 4 cancel, so you're left with your x plus 3 as your final answer. So that one you just have to remember that it's subtract everything in that second fraction. And you also have to remember to factor and cancel whenever possible. So number 3 is very, very similar. So it looks like I definitely have this subtraction. So I have to distribute that. So I'm going to have my t squared, and now I have a minus 5t minus 14. And don't forget that your denominator is the same. So I'm going to have a t minus 7 in my denominator. Now to factor, well, t minus 7, the denominator, doesn't change. It's exactly the same. But if I'm going to factor my numerator, I have a negative 14 and a negative 5. So that would be 7 and 2. If it's a negative 7 plus 2, then it'll give me a negative 5. So I'm going to have this as a t minus 7 and a t plus 2, which tells me that the t minus 7 cancel. So I'm left with a t plus 2 as my final answer. Now, what happens if you have a fraction and they're not the same, right? We're adding or subtracting and our fractions are different. The denominators are different. Well, that tells us that we need to find the LCD, the least common denominator. So let's practice that first before we actually start adding and subtracting. So the only thing we're looking at is going to be the denominators. So if I have a 2 and 16, the lowest common denominator numerically would be 16, okay? Because if you think about it, if I have 2, I have 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. 6 times 2 is 12. 7 times 2 is 14, and 8 times 2 is 16, and 9 times 2 is 18. Now if I were to look at all the multiples of 16, 1 times 16 is 16. Perfect. These both have a 16 in common. So the LCD there will be a 16. So now that I've dealt with the coefficient part of it, now let's look at our variables. So I'm going to look at the x part, okay? So I want the x to be the biggest exponent for the lowest common denominator. So that would be an x to the third power, okay? The next thing I want to look at is my y's. So looking at the y's with the biggest power, I would have a y squared. And don't forget, you actually have a z here. I don't have a z in the first fraction, but I definitely have one in the second fraction. So now I know that my lowest common denominator of those two would be a 16x cubed y squared z, okay? Now let's look at part B. So if I'm looking at part B, remember the only thing I'm looking at is going to be the denominators. So I need to factor each denominator as much as possible. So let's look at this denominator over here. If I do my guess and check, remember hopefully you guys are comfortable with factoring at this point. it would be x times x is x squared, 4 times 5 is 20, and 4 plus 5 is 9. Perfect. So I know that that factored very nicely. Now let's look at that second fraction. So here, x times x is x squared. To get to 16, that would be 4 times 4, and 4 plus 4 would be 8. So I know that's going to factor. So now, if I'm thinking about my lowest common denominator, well, let's think about this. This has an x plus 5. So I need an x plus 5. Now, this is where it gets, I think, students a little bit of trouble. I have 1 x plus 4 here. I have 1 in that green fraction, but I actually have 2. And remember, you want the one with the biggest fraction. So hopefully you remember that x plus 4 times x plus 4 is really just x plus 4 squared. So I know that my denominator is going to have an x plus 4 squared in it, okay? It's one with the biggest exponent. There's 2 of them. Now, looking at letter C, again, it's all about factoring. So if I factor out that first fraction, I have x times x. If I'm going to multiply to 4 and add to 2, that would be a positive 2, positive 2. And now looking at that second fraction, to get to 6 would be 2 times 3. To get to negative 1, it would be a negative 3 and a positive 2. So now that I've factored each fraction separately for each denominator, now I'm going to look at my LCD. So it looks like I have 2 of those x plus 2's, so that's going to be squared. But I also have an x minus 3 that's going to be part of my LCD. For letter D, it looks pretty simple, but it's not. The reason why is because it needs to be written in standard form. So to rewrite it in standard form, it would be a negative z plus 7. And here what you can do is you can actually factor out a negative 1, so you have a z minus a 7. So what this is saying, and I'm only thinking about this fraction here, that's the only thing I'm thinking about. So I have this 1 over 7 minus z, and when I rewrote it in standard form, I get 1 over negative 1 z minus 7. But the really cool and interesting thing about this is that since it's a negative 1, it doesn't matter where the negative is. It just means the entire fraction is negative. So I can actually move it up to the top as a negative 1, and so I still have my z minus 7 on the bottom. So what I really have is I have 6z minus 7, and I have that second fraction as a negative 1 z minus 7. That's from over here. So it looks like the denominators are exactly the same. So my LCD really just is z minus 7. It's already exactly the same. I just had to rewrite it, factor it out, and move that negative to my numerator so that I can see that it's going to be exactly the same. For letter E, I'm going to look at my coefficients. So I have 12 and 8. So if I'm looking at 12 and 8, well, I know that 12 times 2 is 24, and 24 can be divided by 3. So I know that my LCD is definitely going to have a 24 in it. Now, by looking at that C value, well, c to the third is the biggest, and I also have a d to the 5. That's the biggest there as well. For letter F, what I'm seeing is this a squared minus 16. So that can be written as a difference of squares, a plus 4 and a minus 4. And this first fraction is just a plus 4. That's it. So I know that my LCD Well, they both have an a plus 4. That's fine. But I also have my a minus 4 as well. So a plus 4 and a minus 4 ends up becoming my LCD. All right. So that was just your warm-up. So that now we can actually put that into play for the next examples. So it says now to add and subtract as indicated. So the first thing we need to do is make sure that we have an LCD. So if I'm looking at my coefficients 3 and 2, that would be a 6. If I'm looking at my variable p, the biggest exponent is p squared. So now I have 4 over my 3p. Well, let's see. 3, what does that need to get multiplied to get to 6? That would be a 2. What do I need to multiply p to get to a p squared? P. Okay. I have minus my 5, 2p squared. So here my 2 needs to get multiplied by 3, and my p squares match up. So now I have an 8p over 6p squared minus 15 over 6p squared. Perfect. My denominators are now the same. So I have 8p minus 15, and I have a 6p squared in my denominator. And 8 and 15 don't have anything in common, so that's as far as I need to go. Okay, now I am going to look at number 2. So for number 2, I am trying to find my LCD between these two numbers, which is 16 and 10. I believe my LCD between 10 and 16 is going to be 80. I know that 16 times 5 is equal to 80, and 10 times 8 is equal to my 80. So I know that 80 is the first number that they both share in common. So I definitely have my 80. Now I'm going to look at my c variable. It looks like the biggest c is c to the 4th. And the biggest d would be a d to the 5th power. Perfect. Now I have my LCD. So for that first fraction, I have a 3 over 16 c4d to the 5. Now let's compare that with my LCD. Well, 16 to get to 80 would be a 5. C to the 4th already matches, and d to the 5th matches, so I leave that alone. Now I have a subtract. Now I'm going to be looking at my second fraction. So I have a 6 10c squared. So I already know that that 10 needs to get multiplied by an 8. I also know if I want c to the 4, I need 2 more c's on the bottom. So I need to multiply top and bottom by the same thing. And I also need a d to the 5th, top and bottom. So now I have a 15, 80, c4, d5, minus, and 8 times 6 is 48, c squared, d to the 5th, over 80, c4, d5. Now make that look more like an exponent there, d to the 5th power. So because it's subtraction, I'm going to have a 15 minus 48 c squared d5 over 80 c4 d to the 5th power. 15 and 48 definitely have a 3 in common, but 80 cannot be divided by 3. So I'm going to say that is as far as you can go here. Okay. All right. Now looking at number 3, I'm going to have to factor out each denominator differently. So I'm going to look at this first fraction. I'm going to factor out that denominator. So it looks like my GCF is a 5c. So I'm left with a c plus, and then 45 divided by 5 would give me that 9. Now I'm going to look at that second fraction. I have a 5c as my GCF. So I'm left with a c minus, and 40 divided by 5 is going to give me an 8. Okay. So now I know that my LCD is going to be a 5c, c plus 9, and a c minus my 8. So now I'm going to rewrite my fractions. So that first fraction, I have 9, 5c, c plus 9. So I definitely have the 5c. I have the c plus 9. So what's missing is that c minus 8. And whatever I multiply the bottom by, I must multiply the top by as well. Plus, now I have my second fraction. If I'm looking at that second fraction, remember I have a 6 and I have a 5c, c minus 8. So I definitely have the 5c. I have the c minus 8. So what's missing is a c plus 9. So what's missing, I multiply top and bottom by. So now it just becomes a distribution problem. So now I'm going to multiply. So 9c minus, and 9 times 8 is 72, over 5c, c plus 9, c minus 8. Plus, I'm going to distribute here. So I have a 6c plus, and 6 times 9 is a 54. And I have that 5c, c minus 8, c plus 9. And the really cool thing about this is that the denominators are the same, so I can just leave that as 5c, c minus 8, and my c plus 9. So now I get to add my c's together. So remember, I have a 9c, and it's being added to a 6c. I have a negative 72, and I also have a positive 54. So 9 plus 6 is going to give me a 15c. Negative 72 plus 54 is going to give you a negative 18. And all of this is over 5c, c minus 8, and my c plus 9. And I'm just going to make that 15 a little bit nicer. Okay. And so what I can do to take this a step further is that 15 and 18, they have a GCF. That would be a 3. So you're left with a 5c minus, and 18 divided by 3 is 6. And you have your 5c, c minus 8, and c plus 9. Here I thought that something was going to factor and cancel, but it didn't. So this can be your answer, or this would also be your answer. Either one is fine. I just thought maybe if since I pull that 3 out, something would cancel. It's always better to try than not to, but it didn't cancel out. But at least I know for a fact that it can't. Okay, now let's look at number 4. So again, I'm going to just focus on factoring as much as I possibly can. So I'm going to go ahead and factor that first denominator. So 2x times x. To get to 19, that would be a 9 and a 1. So 2 times 9 is an 18, and a negative 1 is a negative 19. Perfect. I factored that correctly. And if you guys need to do the AC method, that's fine. It's whatever you're comfortable with factoring at this point. So that blue fraction, 2x times x, will give me my 2x squared. And I would have a positive and a negative. Okay, so now that that's factored as possible, my LCD, they both have a 2x minus 1 in common. I have an x minus 9, and I need an x plus 1. So for that first fraction, I have 7 over my 2x minus 1, x minus 9, and what I'm missing from the LCD is the x plus 1. So I need to multiply top and bottom by what is missing. For that second fraction, I have that 4x plus 3 in my numerator. My denominator, I have that 2x minus 1 and that x plus 1. So what's missing from this denominator is the x minus the 9. So I always need to multiply by what's missing. So now I am going to distribute. So I have a 7x plus 7. And just so that I can save some room, I'm just going to write LCD for now. And here I'm going to have to FOIL. So 4x times x is a 4x squared. 4 times 9 is a negative 36x. My inner is a positive 3x. And 3 times a negative 9 would give me a negative 27 over my LCD. So I'm going to go over here with my work, just copy it over. So I still have my 7x plus 7 over my LCD. Minus, now I'm going to combine like terms here. I can at least combine that negative 36 and positive 3x. So 4x squared still remains. And now negative 36 plus 3 will give me a negative 33x minus 27 all over my LCD. Don't forget that you're going to take this subtraction and you're going to distribute to everything up on top. So I have my 7x plus 7 minus 4x squared plus 33x plus 27 all over my LCD. And here now you can write it if you want. It was a 2x minus a 1. It was an x minus a 9. And it was an x plus 1. That was my LCD from before. Now when I combine like terms, I have a negative 4x squared in the numerator. I also have 7x and 33x. So 7 plus 33 gives me a positive 40x. And looks like I have a negative 7 and a positive 27. And so that's going to give me a positive 20. And all of this is over my LCD. Well, I know that each thing in the numerator can be divided out by the GCF, and the GCF is going to be a negative 4. So now I have an x squared minus 10x minus 5. And at the bottom, I still have my LCD. So I have a negative 4. And can that factor any further here? Let's see. No, that's as far as I can go. So if I write my LCD back again, I would have my 2x minus 1, x minus 9, and my x plus 1. And the only way 5 can break down is 1 times 5. And there's no way that that can add up to give me a negative 10. So that's how I know that's as far as I can go. So that ends up becoming my final answer. Okay, I know this is a lot of work, but you guys can do this, okay? Now, if I am looking at number 5, with this one, you want to notice that it's not in standard form. So you want to make sure you write it in standard form. So here I'm going to have a negative n plus 5. And you can factor out that negative to be a negative 1 n minus 5. So when I rewrite this as n, 5 minus n, this is really n over my negative 1, n minus 5. And that negative, which is really cool, can be brought up to the top, so it's a negative 1n over n minus 5. So now when I rewrite this fraction, so if I have n over 5 minus n plus 2n minus 5 over n minus 5, well, we already know that this fraction can be rewritten. It's rewritten as a negative 1n over n minus 5 plus that second fraction, which is 2n minus 5 over n minus 5. So now adding like terms, negative 1 plus 2n just gives me an n minus 5 over n minus 5. So since everything cancels, what does that give you? 1 over 1, or better yet, your answer is just going to be 1. Okay? It's like saying 5 divided by 5 is 1. Okay? All right. So that is the end of this section. If you guys have any questions, please feel free to email me or the Max Success Center or our embedded tutor. Thank you.